So yesterday, my husband and I were just talking about everything that's been going on and the craziness, and he's been pretty interested in our number of cases in New Hampshire, that data. He's been kind of following that data each day and trying to figure out if it's starting to flatten out, if it's growing exponentially. And I told him that we've been talking about it in class, so I could actually determine if it is in fact still growing exponentially, and what that would mean for the future. So what I asked him to do is to just give me 2 data points. I asked him to choose a starting date from a few weeks ago, and then we'd use yesterday as the ending date. So the dates that he gave me, I believe his starting date was, he just went onto weather.com, which has a bar graph. You'd have to click over onto state as opposed to county, but I believe he gave me, it was March 15th. We called it day 0, but it had 13 cases. It was 17 days prior. And then yesterday, which was April 1st, he chose as his ending date. So that was 17 days later. And the cases were 367. Okay. So again, we just chose, given 2 points, now you and I can create an exponential equation. Okay. So we learned that exponential equations are written in this form, okay? P of t is where we're ending. So we chose yesterday as our ending number of cases, that was 367. And our starting number of cases was 13, based on the 2 points that we chose, okay? K is what we're looking for to start, and T is our number of days in this case, which is 17. Okay, so now I just need to solve this equation. I'm going to divide both sides by 13. If you do that, you should get this. All right, now we're used to seeing it in a to the x equals b form, so I'm just going to swap that for you. It's up to you if you want to do this or not. I'm sorry, e to the 17x equals 282,308. Okay. And now I can go into my log form. So I'm going to do log base e of my b, which in this case is this number, equals 17x. Okay, so I just converted from exponential form to log form. So log base e we know is ln. From there, you could just type this into your calculator. When I did that, I got 3.3404 equals 17K. And then divide both sides by 17, and you should get this, okay? So then what that means is that our equation, if we go back and write our equation, we have P of t equals, we plug in our starting point, which is 13, E, and my K is this, 0.1965, 0.1965 T, okay? So then what I did was I went on to the calculator. Now, this is not something that we've done in this class, but if you go onto the calculator and you go to second stat plot, which is on the top left-hand side, and you change it so that your stat plot is on, okay? If you do this, make sure later you turn it off. You go to second stat plot and turn it off so that it doesn't get messed up, you know, going forward when you're trying to graph. And then if you go to stat, it's a button kind of in the top middle, and you press stat and edit. And what I did was I went through and I put in all the data points from 0 to 17. I went onto weather.com and I said, okay, 17 days ago it was 13, and then the next day, which I called day 1, was 17, and the next day, which I called day 2, was 26, and I put in all of those data points, okay? So it continues, it goes down all the way to my last one that I put in, which was 17, day 17, where it was 367. Okay, so I put those in, and then I went to graph, and it graphed all of those points for me. Okay, so that's the number of cases that we've had in New Hampshire in the last 17 days. Okay, it actually looks exponential. So then what I did was I went to y equals, and I typed in the equation that we created, basically to see how closely the equation we created follows those points. If it follows those points pretty closely, then that means that this is in fact growing exponentially. So then I clicked graph. So now I have my points as well as my line. If you can see that on there. And you can see that it does actually follow it pretty closely, which means it's certainly not perfect, but it means that it has been following a trend in New Hampshire of growing exponentially. You'll see the way that the points fall, it doesn't look like an exponential exactly. I'm sorry. It kind of instead, the points, if I were to follow the points kind of go like this a little bit, whereas our line looks a little bit more exponential. But it is following that trend, okay? And so from there, if you wanted to predict, now at some point this is gonna flatten out and go down, but we don't know when that's going to happen. So if we wanted to predict, now, if this continues at this rate, what you could do is you could go to second table, which is on the top right, and you could start to see what that means is that you could look at the following days. So that's saying that today it should be 446, which I think is above what it is today. You can even search through, you could figure out, you know, when would say half the population be infected. Now, again, we're hoping that it's gonna slow down and stop and go down before then. But you can make some predictions based on if this trend were to continue. So I just wanted to show you that because it was super relevant to what we've been talking about, what we've been learning.